Right now, artificial intelligence generates more than 75% of Google's new code. Let that sink in for a second. 75%. And both OpenAI and Anthropic are out there claiming that almost every single line of fresh code they produce comes directly from AI. But here's a number that truly captures the sheer unbelievable scale of the AI era we're living in. 4,500. Amazon just recently migrated 30,000 of their production applications from Java 8 to Java 17, and they did it in just a matter of months. Without AI, that exact same project would have taken an estimated 4,500 developer years. I mean, when you look at figures like that, it kind of feels like we're reading the closing pages of an entire profession, doesn't it? But that brings us to a massive, glaring paradox. If AI writing absolutely everything is the ultimate silver bullet, why are most engineering teams actually shipping more bugs, more incidents, and frankly, more technical debt today than they were 2 years ago? The New York Times recently hit the nail on the head, calling it code overload. Teams that just blindly rebuilt their workflows around AI are literally drowning in code churn and security holes. They're just producing way too much code, way too quickly, and it's become completely unmanageable. Okay, let's dive into this explainer. Today, we're working from a really comprehensive guide by Shah Rahman. He's the global head of autonomous ML iteration at Meta, to decode what actually separates the teams drowning in that code overload from the engineers who are pulling off massive 100x productivity gains. Our mission today? To map out the playbook that transitions developers from being just manual coders into absolute master orchestrators. To get us there, we're going to follow a pretty straightforward roadmap. 1. Code overload. 2. The mindset shift. 3. 4 core practices. 4. The agentic development lifecycle. And 5. Security guardrails. Let's jump right into part 1, code overload. So here's your data-driven reality check. Research consistently shows that right around 45% of AI-generated code actually contains security flaws. 45%. A Stanford study even found that developers using AI assistants wrote significantly less secure code. But, and here's the incredibly ironic part, they were simultaneously way more confident that their code was totally secure. On top of that, a randomized controlled trial showed that experienced open-source developers were actually 19% slower when they used AI assistants on familiar code bases. Why? Because of over-reliance without adequate verification. Raw output is just a really poor proxy for actual productivity. That brings us to section 2. The mindset shift. To escape the whole code overload trap, we need a fundamental leap. We have to move from merely writing code to orchestrating AI agents. Think of it like a conductor leading a symphony orchestra. Early in 2025, you might remember the term vibe coding blowing up. It described non-engineers building software basically just by describing what they wanted. And hey, that democratization is awesome, but it is categorically different from AI native engineering. And this brilliantly illustrates the divide. An AI native engineer actually commands and masters AI agents to build things that were literally impossible in the pre-AI era. Knowing how to code remains totally fundamental. Without that baseline, you really are just vibe coding. But with it, you become an orchestrator capable of 100x output. Which leads us perfectly into section 3, 4 core practices. If you look at an AI native engineer's day now, it looks drastically different than it used to. We're talking 40% of your time spent purely on context setting. Only 20% is actually spent on code generation and iteration, and then another 40% goes right into reviewing and verifying. In practice, AI makes the actual generation step incredibly fast. So setting up the exact right context and vigorously verifying the output, that's the real work now. To manage that new time split, you absolutely need 4 foundational disciplines. We're talking Synchronized Context Engineering, Specification-Driven Development, Critical Verification, and Problem Decomposition. Let's quickly break these down to see how they separate true engineering from just, well, everyday chaos. The first one, and honestly, the single most important skill here, is context engineering. This takes your basic prompt engineering and elevates it into something much more robust. It means systematically curating and injecting things like architectural diagrams, business rules, and coding standards right into an AI's working memory, usually using persistent context files like claude.md. Look, the quality of AI output is strictly bounded by the quality of the context it receives. Teams that practice this rigorously, they're reporting 40 to 50% speed increases simply because they aren't constantly having to pause and reline the AI. Next up, you have got to dictate specifications clearly, decompose your problems, and for the love of everything, verify absolutely everything. You just cannot overtrust AI with massive, complex spaghetti code problems. That just leads to context pollution and what people are calling slop generation. Break the tasks down into AI manageable chunks. Let the AI handle the routine 80%, while you step in and handle the edge cases and the highly custom logic. And never, ever skip the review. You really have to treat AI-generated code exactly as if it were written by a super enthusiastic but very early career developer. It needs strict oversight.
Moving right along to Section 4, the Agentic Development Lifecycle.
So the ADLC still consists of 5 familiar key steps, but the human role in them is completely transformed. In the planning phase, you're using agents for parallel exploration. In building, agents handle the end-to-end implementation while you act as the tech lead, orchestrating the whole swarm. Testing becomes basically test-driven development reincarnated, where agents actually write the test plans first. Then you hit a rigorous review phase with specialized agents analyzing functionality, security, and performance. And finally, documentation becomes this continuous real-time process, which finally solves that age-old headache of stale API docs.
Now, here is a massive pro tip for your ADLC. Actively separate your planning, building, and testing agents. By doing this, each agent swarm develops a really deep understanding of your code base, but from a totally different perspective. So a planning agent can actually challenge a building agent if it tries to take a lazy shortcut. A testing agent can catch a review agent's blind spots. You're quite literally creating a system of checks and balances where separate agents hold each other accountable. It's a real game changer.
And that brings us to our final stop, Section 5, Security Guardrails. Because incredible speed brings incredible risk, AI adoption is naturally creating brand new attack surfaces every single day. Now, what's really interesting about this is how we have to systematically map terrifying real-world incidents against the emerging controls required to stop them. For example, a chat integration that was built in just 2 days recently achieved full remote code execution just by exploiting open access lists. The control for that? Strict agent identity and access control with absolutely zero shared credentials. Another wild attack vector is slop squatting, which is where AI hallucinates fake package names and attackers deliberately go out and maliciously register them. Stopping that requires intense infrastructure sandboxing and input filtering to sanitize the context. To actually enforce all of this, you need technical guardrails built right into your pipeline. I'm talking centralized static analysis in your CI/CD pipelines, especially since up to 30% of AI-generated Python snippets contain weaknesses. You need automated quality gates with iterative verification loops. And most importantly, mandatory human review is still absolutely 100% required for critical functions. Things like authentication, payments, handling PII, you simply cannot automate that away. Don't even try. So what does this all mean for the future of our profession? Well, as we look toward the engineer of 2026, the biggest takeaway is that AI amplifies expertise. It doesn't replace it. Human systems thinking, critical judgment, and communication skills, those are the elements AI simply cannot replicate. Your specific domain expertise, whether that's in finance, science, math, or whatever field you're in, is your ultimate differentiator. And that leaves us with a critical question to think about as we wrap up this explainer. I want you to take a hard look at your current workflows. Are you just treating AI as a quick, handy tool to write a few fast lines of code? Or are you fundamentally rebuilding how you orchestrate software from the ground up? To thrive in this new era, you really have to choose to be the orchestrator. Thanks so much for joining me on this explainer, and I highly encourage you to start applying these principles to your own development cycle today. Catch you next time.